So let's talk about hurricane hunters and aircraft reconnaissance in atmospheric rivers. First of all, how long has this been going on? Because this feels like a new concept of flying into atmospheric rivers.
Yeah, so this has been going on. The atmospheric river reconnaissance has been going on for about 5 years with the Hurricane Hunter aircraft. So that's the Air Force Reserve Command C-130s and the NOAA G4 who fly into hurricanes during the summer and fall. And really it started as a research program. So at first we would only be able to do a couple of flights per year. In the first couple of years of Air Recon, I think in 2016 there were maybe 3 flights, and that kept increasing. But as we found really specific improvements in the forecast through using these aircraft, in 2019, after that season, we got put into the National Winter Season Operations Plan. And so that then made the mission operational and enabled us to do a lot more flights into atmospheric river storms. So we've been continuing to expand based on, one, the needs of the program. So like as we define how important the flights are for West Coast weather forecasts, then we also say, oh, well, for example, this past year, in 2022, when we flew January, February, it was very, very quiet in California. We do this in partnership with the California Department of Water Resources to provide more information for California. So that's a really important state for us. Of course, we're flying anything that affects the US West Coast in general. But last year, there really weren't storms in January and February. So that motivated this year for us to start on November 1st instead of waiting until January 1st. So we are really responsive, I think, towards the results that are coming out of the program and towards the needs of the Western US.
So take me through what a flight is like and how it differs from hurricane hunters reconnaissance.
Yeah, so I think there are a couple of really key differences, and one is the altitude at which the planes fly. So the other thing, of course, is that hurricanes and atmospheric rivers are structurally very, very different. Yes, they both have lots of water and lots of wind, but that kind of ends their similarities. So atmospheric rivers are really long and narrow plumes of intense moisture transport. So lots of vapor, lots of water, lots of wind, but in a long plume. Whereas hurricanes are, of course, these like circular, they can be very large, but they're a very particular sort of shape and structure. So it's really critical for us to be able to design particular flight tracks to best sample the individual atmospheric river that we're looking at that time. So one big difference is that the hurricane hunters, when they're flying into a hurricane, are flying at much lower altitudes, usually about 10,000 or so feet. And then when we're in atmospheric rivers, what we want to do is get a complete profile of the AR. And so they're flying much higher at like 26,000 or even 30,000 feet. The G4 aircraft is flying even higher than that, usually about 41 or 42,000 feet. So I guess the two main differences, to answer your question, are the altitude at which the aircraft fly, and then also the flight track patterns which they fly are quite different from what they fly in hurricanes.
Yeah, how do you decide what the flight pattern is? Because it's such a huge space that you have to cover, right?
Yeah, that's a great question. So our first priority is to look at essential atmospheric structures. So we know where there's the largest amount of uncertainty physically and what the models have the most trouble with, which is in and near the atmospheric river, and in particular in areas of high gradients, of high like moisture gradients and things like that. So we know to focus on those. We also know that atmospheric rivers have a lot of their water and wind in the lowest levels of the atmosphere. So when associated with also high clouds, these are really difficult for satellites to see in any detail. And so that's why we want to supplement kind of what is our conventional global observing system with these extra profiles that the dropsondes provide us of temperature, moisture, wind, and pressure. So basically, we have a forecast brief every morning where we then design a flight track for that particular storm based on what our physical knowledge is of where those observations would be most helpful. But then we also use a couple of different mathematical techniques to supplement that forecast. And it's kind of like jargony mathematical stuff, but there's an adjoint model that we use that comes out of the Naval Research Laboratory that basically does small perturbations of the initial conditions to basically say, like, if the moisture is a little bit different here, how does that affect precipitation? And I should have said first, we also define a box where we care about where the precipitation is falling. So recently it's been like over California. If it was a Pacific Northwest storm, we draw the box over Washington and Oregon. So that's one technique. And then we also use ensemble sensitivities. So many of the models are run not just one sort of resolution of the model, or not once, I can't think of the right word, but one version of the model, but a lot of different versions to create an ensemble. And so we also kind of look at what are the highest variability in the ensemble, like where's the higher standard deviation of precipitation within a box that we define, that we care about, and then looking upstream, where do small changes make big changes in that precipitation forecast. And so then we can make an observation there, and then we can constrain the model a little bit better by giving it observational information to use for its forecast, and the goal of making the forecast better in that area.
What have been some kind of surprising things that you've learned over the past couple of years with this sort of research?
Yeah, that's a great question too. So we've actually learned a lot about atmospheric rivers with these observations. So they're used immediately to go straight into the forecast and improve an operational forecast, or straight into the models and improve an operational forecast. But we also use them after the fact to look at atmospheric river structure and evolution and try to better understand those basic fundamental physics, such that we can improve the overall model representation of these phenomena. So that's a bit of a longer timescale forecast improvement. And some of the things that we've learned include lots of really interesting details about exactly how strong the atmospheric river can get. That fact that there's kind of like not a symmetry on both sides of the AR, but there's sort of differences depending on if you're on the cold side or the warm side. And so that's been really exciting just to learn more about the structure. There was also a paper that came out a few years ago that used dropsonde information to basically understand a cross section of what the atmospheric river looks like. And so, for example, that 75% of the moisture in an atmospheric river is in the lowest 3 kilometers, and things like that, just so we can assess, are the models representing these properly? But it's really exciting, all the sorts of research and its science advances that dropsondes can enable.
Do you just fly into every atmospheric river? How do you decide?
Yeah, so we have a few different phases as of this year of atmospheric river reconnaissance. In November and December, we were what was called resource permitting with the C-130s. So we were really focusing on storms that would be extra impactful for the US West Coast. We are now in a season that is on station. So of course, we are still flying anything that would be impactful for the US West Coast. And when I say impactful, that also means for water supply concerns, as well as for hazardous flooding concerns that we were seeing in this Central California throughout this past family of atmospheric rivers that we were just flying. But we also have a few other kind of science objectives when we are on station with the aircraft. So we are what we are kind of framing as a research and operations partnership. So one other really exciting thing that we are doing is, for storms that affect the West Coast, sometimes they also have, of course, downstream impacts later in the forecast on the Midwest or on the East Coast. And so we are also kind of tracking, like, what are our impacts on those more downstream impacts, even if it's maybe a weaker storm on the US West Coast. So basically, my answer to your question is it depends on what part of the season we're in, on what types of things that we fly. But we do try to take advantage of having the aircraft out here and flying everything we can if we think we can make some kind of advancement in forecasting by using those observations.
Interesting. Do you think we'll ever get to a point where they're named, like hurricanes are named, and that we have a specific season and a specific, like all of these specific things that we have for hurricane forecasting and outlooks? Do you think that we'll get to that point with atmospheric rivers, especially in a changing climate?
Yeah, I think that is a great question as well. And I'm not sure about the naming, but honestly, I don't know that I would have predicted the ranking system either. And it has really turned out to be useful. I think like some of the challenges with the hurricane system, as we're seeing in a changing climate, are that just using the maximum wind speed may not give you a full picture of all the impacts. And I'm not claiming that the AR rank does that either, because you have to also consider like we have often these families of ARs. Thank God that doesn't happen with hurricanes yet. But like, if you have an AR2, but it's on the back of 3 AR3s in a row, that's going to be way different impacts than if you have an AR2 that's just coming kind of on its own. So, but I think that what we tried to do with the ranking system is include information not only on intensity, but also duration. So I didn't anticipate the ranks. I cannot say no about the naming. And I do think that, basically the answer that everyone wants in terms of California water management in Western states in general is, how many ARs are we going to see this year and by category? And so similar to hurricanes, we are not really in a place where we have any skill in that answer right now, but there is a lot of ongoing work to try to be better at that at the sub-seasonal to seasonal scale. So anywhere from like 2 weeks out to even longer. And there is a whole group of folks at the center I work for, who are working closely with the Department of Water Resources and others to really try to get better at that answer. So I strongly hope we will be seeing things like that in the coming years. I guess the only thing else I'll add is just how important the partnerships that we have with this are. Like, we have a whole steering committee, which includes senior scientists from the operational numerical weather prediction centers, and having their input directly, just with their knowledge of the models on where the observations might be most useful. And then also to design data impact studies for us to assess, okay, so this was the goal of these observations. Did we do that? Did we do what we think we did? Is really, really critical and important. And then also having our Air Force colleagues out here at Scripps with us to do the flight track designs in person has been extremely helpful and efficient, because there's all sorts of like considerations with how close you can be from the coast, warning areas that might pop up for the military, and things like that. So having those partnerships is really, really critical for the success of this program. It's a lot of diverse folks who are participating.
Yeah, it sounds immediate impacts as far as modeling, right?
Yeah. Yeah.
So where do the flights go out of?
Well, this year they are going out of Mather Airfield, which is near Sacramento, for the C-130s, and the NOAA G4 is out of Honolulu. But we have basically, that's also an ongoing process that we interrogate each year. The C-130s have also flown out of Reno, they've flown out of Brownfield, they've flown out of Travis Air Force Base, out of Portland, and the the G4 similarly has had a number of different bases. So we do thoughtfully consider that before each year to try to get them in the optimum place to be able to get the targets.